Example number 6, log base 5 of x plus 4 equals log base 5 of 2 minus x. To solve logarithmic equations, you usually want to make it 1 log equal to 1 log. Logs are just not usually empty. They should probably have a base on them. Or 1 log equal to 1 number. In the first one, these need to be logs of the same base. So, I'm going to squeeze it in down here. Need to have same base. Okay, so, but this is kind of like step 1. And please don't skip step 1. You have to have 1 log equal to 1 log or 1 log equal to 1 number. When it's 1 log equal to 1 log, they need to be log of the same base. So log base 5 of x plus 4 equals log base 5 of 2 minus x is this 1 log equal to 1 log situation. Once you are in 1 log equal to 1 log or 1 log equal to 1 number, you are then going to step 2 and base both sides. Now, when we base both sides, we are writing our base big and down because we are turning our log base 5 of x plus 4 and our log base 5 of 2 minus x into exponents. Because 5 raised to the log base 5 cancels and x plus 4 falls out. And that's going to equal 5 raised to the log base 5 cancels and 2 minus x falls out. Step 3 is simplify and solve for x. Not simply, simplify and solve for x. So we simplified when we did 5 raised to the log base 5 of x plus 4 cancels and 5 raised to the log base 5 of 2 minus x cancels. Now to solve this guy for x, he is a linear equation. To solve that, we do x's on one side, numbers on the other, and that will give us 2x equals negative 2, divide by 2 to get that x equals negative 1. And the last step, which is also not optional on logarithmic equations, is you need to check to make sure. So make sure your answer or answers do not make the inside of an original log 0 or negative. Do not make the inside of an original log zero or negative. There is a restriction on a logarithm's domain. What goes inside of a log cannot be 0 or negative. And so, am I saying that you can't have negative answers? No, I am not saying that. I am, however, saying that we need to take this negative 1 and substitute him in place of x and see if he makes the inside of the log 0 or negative. Now when I put -1 for x onto the left-hand side, -1 plus 4 is +3. That's perfectly fine. 2 minus -1 minus negative becomes plus positive. That's also 3. He does not make the inside of my original log 0 or negative, which is why we solution set -1. And here is a prime example of, I am not saying that we throw out negatives, I'm saying we check if our answer makes the inside of our original log 0 or negative. This -1 doesn't make either one 0 or negative, and so we keep him. Okay, now, 2 things that I want to point out. Logarithmic equations are much easier to spot. Why? Because they have a log or an ln. Much easier to spot compared to an exponential equation where x is trapped up in the exponent. The other thing is that there are less cases. We want 1 log equal to 1 log or 1 log equal to 1 number. I feel like I should circle this also, even though I don't have a note about it. But my circle got weird, so let me try again. And so I would say this simplified, they're easier to spot, less cases to deal with, does make them overall easier than exponential equations. Now, usually, I chose that word for a reason, because of course there's that oddball time where one of those 2 things doesn't work. Last thing, basing both sides is different than log base being both sides. When you log base b both sides, it is on a new step, and log is big and on the line, and you are just transferring the step above it to the step below with your new log guys in front. We were log base 10ing both sides, which is just written log. That's why we don't see a base there. And when we base both sides, we are purposely writing our base big and down to turn what was already there in normal size into an exponent. Now, what usually happens after this with students when we are face-to-face in class is after I teach people to base both sides, well, then they want to log both sides like we base both sides. And so by that I mean, let me just take and copy and paste over here. Although I picked a terrible spot to do it in, okay. Then let me erase some of the stuff that I messed it up with. So rather than doing it as a new step on the line below, what students usually start doing after they learn to base both sides is they want to write log big and down. But this is not an exponent. Basing both sides and log base being both sides is not the same thing. You do not just get to try to squeeze him in. It does need to be a whole nother line, like what I had here before, where on the next line down, you write log big, and on the same line as your base with the x in his exponent, your log with the guy that was on the other side of the equal sign. How you write the 2 of them is just different. If you don't write them correctly, I will take a point off. So just know that going in. Okay, so Next, this guy, number 7, log base 3 of log base 3 of 2x is equal to negative 2. This is 1 log equal to 1 number. Once I have 1 log equal to 1 number, I am ready to base both sides. So I get to 3 both sides. Oh, I know what else I forgot to say. And that is that books don't teach you to base both sides like I do. My way is better. Usually if we were face to face, I would show you the way that the book does show you to do it, show you that my way's better and actually the same, and kind of tell you as long as you do it correctly, I would give you full credit. But since everything is take home in this class, you don't get options. I'm just going to warn you, if you view an example in the homework, it will probably confuse you because they don't teach you to base both sides. But I've had lots of success with basing both sides because students like to do this. It's kind of fun. Why are we basing both sides? Because exponentials and logarithms are opposites, like plus, minus, multiply, divide, squared and square root. They undo each other. So 3 raised to the log base 3 cancels, and log base 3 of 2x falls out. 3 to the negative 2 power is 1 over 3 squared, or 1/9. Once I have 1 log equal to 1 number, oh look, it happened again. How do I solve him? I still base both sides. And this gives me 3 raised to the log base 3 cancels and 2x falls out. That is 3 to the 1/9, or I should know that 3 to the 1/9 power is actually the same as the 9th root of 3. To finish solving for x, I divide by 2 to get that x equals the 9th root of 3 divided by 2. This is my exact answer. I just need to make sure that this guy does not make the inside of my original log 0 or negative. And then that guy doesn't make the inside of the next log, I guess, 0 or negative. The original directions did say give an exact answer and an approximation rounded to 4 decimal places. So you need to know how to work your own calculator. I'm going to 9th root 3 in my calculator and then divide that answer by 2. And I get that x is approximately 0.5649. Next to the 9 is a 1, telling me to stay a 9. And these are the 2 answers I'll be looking for on your paper. Now, 2 times this guy inside of here is going to be a positive. That's fine. But what about log base 3 of this guy? Does he equal a negative that I then can't put in the outside log base 3? He's actually, once I plug in the... All right, I'm going to have to actually write this out even though I was trying to avoid it. All right, so log base 3 of 2 times the 9th root of 3 divided by 2. What I'm looking at, does it make the inside of an original log 0 or negative? So these 2's cancel. And I am taking the log base 3 of 3 to the 1/9. Log base 3 of 3 to the 1/9, log base 3 of 3 cancels and 1/9 falls out. Am I allowed to log base 3 1/9? absolutely. Is the inside of an original log 0 or negative? No, which is why we keep our answer. Now, could I have actually been checking him this whole time? Does he equal negative 2? Does he equal negative 2? Yes, I could check him, and log base 3 of 1/9 is in fact negative 2, so it works and it checks. But we don't actually have to check our answers. We just have to make sure that our answer or answers do not make the inside of an original log 0 or negative. And that's really all I'm trying to check for. Okay, now I'm going to pause my video and then do example number 8.